Hey guys, this is Moib here from the University of Greenwich. In this video we're going to be looking at circle theorems. And before we begin and start looking at some actual examples, I want to go through some of the terms that they might use when you're dealing with these type of questions. And also we're going to go through the three key theorems that we're going to need for these questions. So let's get to it. So the first thing we want to do is we want to identify all the keywords that they may use when dealing with circle questions. Okay, I think the first one that is most vital and that most of you probably already know is this line that goes all the way around the outer side of the circle. Okay, this is known as your circumference. Okay, so this just refers to this black line that makes your circle. Okay, so moving on, let's look at this green line that goes from one side of your circumference straight through the middle and touches the other side of your circle. Okay, this is known as your diameter. Okay, this is not your radius. Okay, a lot of people get mixed up with this. Your radius is in fact this blue line over here that goes from your midpoint and touches the circle on its circumference. So this is your radius. Okay, so now moving on, this little shaded area here, shaded in green, is known as a sector. Okay, this is when two radii combine together to create a portion of the triangle, and the portion is known as the sector here. Okay, so that's when two radii combine together and give you the sector. Moving on, we're going to look at this red line here that goes from one side of the circle and it joins at the other side of the circumference. Okay, this is known as a chord. Okay, so it's kind of the same as the diameter, as in it touches two sides of the circumference, but the diameter goes specifically through the midpoint. A chord can be anywhere as long as it doesn't go through the midpoint. If it was to go through the midpoint, it would be a diameter. Okay, so a chord is anything else that touches two sides of the circumference. A straight line that touches two sides of the circumference. Sorry about that, guys. There was a slight problem with the recording. I didn't manage to capture the bit where I talked about one of the definitions. Okay, so let me just go through this again. The red line that goes from one side of the circumference to the other is known as a chord, so long as it doesn't go through the midpoint. If it was to go through the midpoint, it would be a diameter. So this red line is again a chord. And now the region that's shaded in is known as your segment. Okay? Whenever there's a chord present, a chord would always separate the circle into two segments. Okay? This is a segment over here because it is separated by a chord, and this will be another segment. Okay? In questions, they usually refer to the smaller segment as the smaller segment and the larger segment as the larger segment. So again, whenever there's a chord present, the chord would always separate the circle into two segments. Okay, so this will be one segment of the circle, and this will be the larger segment. And finally, the last keyword we're going to go through is this line here, which just touches the circle at one point in the circumference, and this is known as your tangent. Okay, so that's when a line goes and touches the circle at one point. This tangent will always be perpendicular to your diameter. Okay, your diameter is actually 360 degrees, so all the way around your diameter, say your diameter is 3 centimeters, it will be 3 centimeters all the way around 360 degrees. Okay, now when your tangent comes and joins the circle at one point, this will always be perpendicular to your diameter. So now that we've gone through the keywords that will be used, we're going to go in and look at some of the theorems that we need to know for our exam. Just a point on the keywords, make sure you know them. It will be extremely important in your exam, and also for the rest of the videos that are going to be on circle theorem, I will be using these keywords. So it's important that you know these. So if you don't know them, go back, pause it, write it down, and just make sure that you know them. Okay. So over here we've got a diagram that illustrates our first circle theorem. Okay. Here the angle created by AOB is twice as large as the angle created by ACB. Okay, so let's just write that out. The angle AOB is twice as large as angle ACB. ACB. So let's look at this diagram for a bit. Okay, so you see that you've got a point A and a point B which meet at the midpoint, and you've also got another set of lines that start from point A and point B and meet at angle C, which is on the circumference. Okay, the angle that 2 points make when they join at the midpoint. Okay, so this is the midpoint. The angle that these 2 points make at the midpoint is twice as big as the angle that these two same points will make when they join to the circumference. Okay, notice that it will always happen in this form. Okay, these two lines could stretch out over here, starting from these 2 points. This will also be x. Okay, so regardless of where it touches, it could touch anywhere. It could even go here, and this will still be an x. So I've changed the diagram up a bit, and we see that we've got 2 points again that create 2 angles. We've got A and B, AO and B, which create the angle of x, and AC and B, which create the angle of 30. We see that A creates 2 angles, one with the midpoint and one with the circumference. As soon as we see this pattern in any of our questions that we come across, we know that this angle is going to be half of this angle. Okay, so the angle created at the midpoint is always going to be 2 times double what this value is. So we know x is going to equal 60. Okay, angle AOB is 2 times angle ACB. Okay, angle is made from the midpoint and angle is made from the circumference. That's what you need to look out for when using this theorem. Okay, so now moving on to our circle theorem number 2. This is going to involve the diameter. Okay, I've denoted this with a green line, and this theorem states that any 2 angles created using the diameter, so I'll just draw it in, that touches the circumference is always a right angle. Okay, so even if it was this side round, because this is the diameter, the 2 points are at each side of the diameter, these two are going to be right angles. Okay, so that's your second circle theorem. So moving on to the last theorem we're going to go through in this video, we see that all these angles that come from 2 points that touch the circumference are the same only when they go and touch the circumference on the same side of the segment. Okay, going back to what we were talking about earlier about keywords, your segment is the line that touches the circle at 2 points of the circumference which does not go through the midpoint. Okay, so over here you can see that A and B is a chord. Okay, we've drawn an imaginary line in which is a chord, and every angle that is created from these 2 points that touch the circumference at the same side of the segment, this is a segment here, this is another segment here. Okay, so let's call this segment 1 and segment 2. Okay, and these 2 segments are separated by this imaginary chord. Okay, so you can draw as many angles which touch the circumference on this side of the segment, and these angles will always be the same as long as it goes to the circumference. So I could draw another one in there. Sorry, that would be an x as well. So whatever these angles are, they're always going to be the same. However, if it was to go in this angle, this will not be x. Okay, it has to be at the same side. Alright, thanks for watching, guys. This was just a quick reminder of some of the keywords that you should have come across already. In the next video, we're going to look at some of these theorems in action as we're going to go through some complicated examples.